comparing multiple alternatives or multiple projects whose useful lives are not exact same. In this case, we are comparing these three projects where A goes for 6 years, C goes for 4 years. So there are two ways you can solve this problem. One is called the repeatability assumption. So each of these projects will repeat until the one of the common numbers. So in this case, 12 years. So A will repeat twice, C will repeat 3 times. So they will go up to 12 years. That's called repeatability assumption. So you're going to be solving these based on the repeatability assumption in this video. So we'll have to basically repeat these for 12 years. So that's 12. Excel is pretty smart. It's making everything dollar. It knows I'm talking about money. So the cash flow, first year you're going to invest $100,000 for project A, and then we are generating a annual cash flow of this minus these. I'm gonna be freezing both of them. I'll probably not freeze this now. I'll just leave it like that. So this plus this is already negative, so it's going to be plus. And then we have the maybe I can do this like this. So these are the cash flow we're going to get for these 12 years. However, project A, we have to reinvest that after 6 years. So I need this again. And then also I'll get back this end life value, which is this $20,000. So that's gonna be that year 6 cash flow. And then last year we'll get that end life market value, which is this 20,000, summing this. So this is the cash flow for project A. For cash flow for project B is simple. There is no investment going on. So you can simply do this and then equal to this plus this. And I can simply type this guy equal, copy it all the way down. And it has some market value at the end life, which is this. So that's going to be my cash flow for B. And for C, the cash flow for C would be basically this. And then the annual cash flow I'm generating plus this guy equal to this. And this project only continue for 4 years. So every 4 years, I'll have to make another investment of this much. And also I'll get back this end life value. So then another investment gonna be at 8 years. So that plus the end life value. And then finally, I'll get this end of life market value at the end. So this is the cash flow for each of these project A, B, and C. Now we're going to calculate the present worth for A. If the question is asking for calculating that, so simply you can type that PV function. So each of these cash flow will consider that is happening at the future. So for example, this 30,000 is coming after 10 years, and we are bringing everything into year 0. So it's going to be 20% rate. Everything is in same rate. I'll freeze that cell so I can again and again use that. And then we're going to be using this for the number of period compounding, because the first $100,000 is not going to compound. There is no payment. We're only converting these future values. So I'm going to be using negative sign so that I get the desired sign. And then simply I can copy like this. Oh, okay, here we go. It should be fine now. And you go here and then copy down all the way. So that's all the present worth for this project. So I can simply type the present worth here and then simply sum this. So that's the total present worth for A. I can just copy this Excel is not so smart. It's not now. It's so that's the different so present value for each of these projects. So to summarize, based on the repeatability assumption, you simply repeat that projects until to a common study period, and then so that you have a common baseline. Now, the easiest way to solve this type of problem, simply you can calculate the annual worth, not even doing this cash flow. You can simply type that function called PMT and then use this rate, number of compounding period. That is only 6 years because it will continuously doing the same thing. So the annual worth it's gonna be same. You really don't have to go up to 12 years for the repeatability assumption. And then present value. So that's what we are investing at the present. And then the future value, which is use a negative sign again, this one, and then 0 at the end of period interest compounding convention, plus these two annual cash flow. One is the revenue, other one is the expense. So that's going to be the annual cash flow for each of these projects, and you can make a decision whichever gives you the best. As you can see that B gives you the best. Now to kind of show you that you can calculate this annual cash flow from this present value we have calculated, just to verify you have done everything correctly or not. So basically you can compound it for 12 years. That's the present value that we have calculated for repeating that assumption. There's no future value. Everything was counted in there. So as simple as that. As you can see, this is the exact same number as we have got in from this directly using the annual worth. So if you use the repeatability assumption, and if the question is asking which project to choose, you can simply calculate the annual worth quickly and make a decision on that. And if the question is asking present, future, you can always develop this cash flow table and do the calculation accordingly. Now, if you calculate IRR, if the question is asking for IRR, you have to do this cash flow diagram. Otherwise, it's not going to give you there is no way in Excel you can do that. So once you do that, you can get the IRR and then make a decision based on that. So percentage, let me get a couple of decimal points, see which one is giving the best. Again, the project B has the highest IRR in this case. So if you have to choose one of these projects, then B is the most attractive one based on the present worth, future worth, IRR. And as you can see, all of them are feasible based on the minimum attractive rate of return because they're all over 20%. That's your minimum desired return. So any of them could be potential alternative. However, the B is the best out of these 3 options.